From these sprawling complexes, the future of glass manufacturing takes shape, a blend of raw power and polished precision. This is the furnace room, the fiery core of the factory, where the raw materials are melted down before taking shape.
Molten glass, glowing like the sun, is the lifeblood of the Tumbler factory, a mesmerizing dance of heat and viscosity. Molten glass, glowing like the sun, is the lifeblood of the Tumbler factory, a mesmerizing dance of heat and viscosity.
Glassmaking requires 4 primary ingredients: silica sand, soda ash, limestone, and recycled broken glass known as cullet.
This is silica sand, the primary ingredient in glass. Its crystalline structure is key to the tumbler manufacturing process.
Here in the factory, the process begins with the careful measurement of silica sand, the primary ingredient for our glass tumblers.
The heart of the operation is the batch mixer, where raw materials are continuously fed via conveyor for thorough homogenization.
The journey begins as precise measurements of silica and other compounds are fed into the rotating drum.
Maintaining a temperature of nearly 3,000 degrees Fahrenheit, this furnace is the beginning of every piece of glass we produce.
The raw materials cascade into the searing heat of the furnace, beginning the crucial transformation into molten glass.
This is the heart of the operation, where silica sand is transformed into liquid fire at over 1,500 degrees Celsius. Here, deep within the furnace, the raw materials are transformed. The gauge climbs past 1400, the melting point of glass. Heated within the crucible, these desaturated materials transition dramatically, flowing into the saturated, glowing orange liquid we know as glass. At over 2,000 degrees Fahrenheit, the glass begins to reveal its secrets as trapped carbon dioxide rises to the surface.
Controlling the flow of heat is critical. Here, surrounded by the roar of the furnace, the glass begins its transformation.
These refractory bricks are designed to withstand extreme conditions, but even they show the strain of constant operation in the glass melting process.
From this glowing stream, the factory can produce over 200,000 glass tumblers every day.
Shot in extreme slow motion, we witness the final stage of purification, as the last impurities ignite and vanish.
As the glass moves into the conditioning zone, the temperature gradient becomes visible, crucial for shaping.
The homogenization process is critical to ensuring the glass is perfectly uniform before shaping. The heart of the factory lies in the pressing machine, where massive hydraulic arms shape the molten glass with pinpoint precision. The molten gob, glowing with intense heat, is perfectly severed by the shears and guided into the pressing mold below. At over 2,000 degrees Fahrenheit, the gob hits the mold, perfectly timed to ensure structural integrity as it forms the tumbler. This mechanical transformation is the heart of the process, shaping the raw glass into a perfect tumbler with immense pressure. Under immense pressure, the molten blob begins its transformation, spreading rapidly to fill the intricate details of the mold.
Shot in ultra-high definition, we can witness the precise moment the decorative pattern is embossed into the superheated surface. Once the mold splits, the steam escapes, and the newly formed tumbler begins its long cooling process.
This sophisticated robotic arm uses a specialized vacuum gripper to extract the freshly molded tumbler, still glowing with intense heat. The robotic arm precisely deposits the glowing tumbler, still radiating intense heat, onto the mesh belt for controlled cooling.
The precision required for the automated cycle is immense. Even the slightest adjustment can affect the structural integrity of the glass.
Fresh from the press, the tumblers begin their journey toward the annealing layer, where controlled cooling removes the stress from the glass.
Between cycles, the molds must be cleared of any residue. A sharp blast of compressed air ensures the cavity is perfectly clean for the next pour. The extreme heat creates this mesmerizing shimmer. The molten glass, still vibrant cherry red, shows the precision of the pressing process. The key to the new design lies in this different mold configuration, allowing the geometric pattern to be precisely pressed into the textured tumbler.
Quality control is paramount. This tumbler, despite its vibrant color, contains a critical flaw. The automated system swiftly
The IS machine, as it's known, is a marvel of industrial engineering.
blowing glass with precision across multiple synchronized sections.
In stunning slow motion, the incandescent gob descends into the mold. This is the precise moment the tumbler begins to take shape. The settle blow mechanism descends, applying compressed air into the gob. This initial shaping creates the parison within the tumbler mold.
In this macro visualization, we see the parison formation. The molten glass expands rapidly.
The inversion mechanism rotates with mechanical precision, transferring the glowing parison to the blow mold station.
The synchronized movement of the robotic grippers ensures the molten parison reaches the blow mold with pinpoint accuracy, ready for the final stage of inflation.
The expansion is rapid. This final burst of compressed air forces the molten material outwards, finalizing the tumbler's shape.
The synchronized movement of these robotic arms ensures the structural integrity of the glass as it begins its crucial cooling phase.
Here we see the precise moment of the dead plate transfer. The superheated glass begins to cool rapidly before the robotic arm pushes it onto the conveyor. A cinematic wide shot reveals the synchronized sequence of the blowing machines. It is a choreographed industrial
The blowhead mechanism is the heart of the forming process. Compressed air is precisely timed to shape the molten glass inside the molds.
As the pressurized air fills the mold, the molten glass is stretched in slow motion, transforming the glowing orb.
Through a specialized time-lapse, we observe the critical cooling phase. The vibrant orange must fade to a...
The pusher arm transfers the cooled tumbler from the dead plate onto the annealing layer, initiating the controlled cooling phase.
As the molds separate, the intense heat reveals the perfectly formed tumbler, glowing with the raw energy of creation.
The annealing layer, stretching over 40 meters, is where the glass begins its slow journey towards stability. This is the layer entrance. The tumblers, glowing at over 1,000 degrees, begin their slow journey through the annealing oven.
This is the layer entrance, the first heating zone. The tumblers reach temperatures of 550 degrees Celsius here, preparing them for the annealing process.
Inside the annealing oven, we see the extreme temperature gradient as the glass slowly cools from over 1,000 degrees to near room temperature.
The annealing process is crucial. As the glass slowly cools, the vibrant stress patterns seen here under polarized...
Mid-layer monitoring is critical. We see the temperature gauge showing controlled cooling, moving precisely from 5...
This heavy-duty conveyor system moves the freshly molded glass into the annealing oven, a process essential for strengthening the final product.
As the tumblers slowly traverse the conveyor, the dramatic cooling gradient is revealed, from vibrant red to cool black.
Meticulously controlled cooling is essential. The glass slowly stabilizes, its fiery heart now just a subtle warmth.
The annealing process is critical. As the tumblers exit the layer, they slowly cool to ambient temperature.
Precision is everything in the annealing process. A slight adjustment to the burners ensures the structural integrity of the glass tumblers.
The annealing cycle is now complete. The dramatic transformation from lead to crystal transparency.
Utilizing state-of-the-art machine vision, this line inspects hundreds of glass tumblers per minute, maintaining the highest standards of clarity and finish.
Shot in stunning 4K, this cinematic footage highlights our commitment to quality. Each tumbler is meticulously inspected under the bright ring light. Utilizing advanced optical sensors, the system captures thousands of images per second, ensuring flawless quality control for every unit. This tiny air bubble, trapped during the cooling process, represents a critical quality defect. While beautiful through polarized light inspection, we can clearly see the birefringence caused by stress. The bright white indication confirms the presence of a crack in the tumbler.
This is the reject mechanism in action. The pneumatic pusher arm swiftly removes any defective items. Once the tumblers are accepted, they continue their journey toward the finishing operations, a seamless blend of precision engineering and automation.
The finishing process is critical. These diamond-tipped wheels, cooled by a constant spray, smooth the rim to ensure a perfect finish.
In ultra-slow motion, we witness the precise moment the diamond wheel meets the glass, a symphony of abrasion and cooling.
Here we see the meticulous polishing process. The soft studio lighting catches the perfectly smooth.
This is the flame polishing station. The tumbler's rim passes through the intense natural gas flame, smoothing the surface to a perfect finish.
To achieve the perfect frosted finish, the clear tumblers are submerged in the hydrofluoric acid bath, a highly precise chemical reaction.
Here at the washing station, high-pressure jets remove even the finest grinding residue, ensuring a crystal clear finish.
The finishing process relies on this superheated drying tunnel. Blasted with hot air, the tumblers emerge.
The final visual inspection is the most crucial step. Here, the human eye detects flaws that machines might miss. The digital caliper allows for highly accurate measurement of the tumbler's diameter and wall thickness during the quality inspection process.
The stunning prismatic effects seen here are a testament to the purity of the glass.
Once approved, the crystal clear glasses are precisely sorted by size and style onto different lanes, ensuring organizational efficiency.
Our state-of-the-art decoration department combines precision screen printing and laser etching, followed by a protective coating.
The screen printing process is highly precise. As the squeegee moves across the frame, it forces the
Using a thick rubber squeegee, the vibrant ceramic ink is slowly transferred through the mesh directly onto the glass surface.
Here we see the cyan layer being applied, perfectly matching the registration marks of the magenta base. To fuse the ceramic ink, the tumblers enter the kiln's 600 degrees Celsius environment. This critical
The fusion process ensures the vibrant colors are permanently etched into the surface of the glass, creating a seamless bond that will last a lifetime.
Harnessing the power of focused light, the automated machine creates intricate patterns in seconds, a truly modern decoration technique. The laser applies precise thermal shock, creating controlled microfractures that result in this beautiful frosted pattern.
Utilizing fine, high-pressure abrasive media, the worker expertly transforms the transparent tumbler.
This macro view highlights the steady brush stroke, transforming the transparent glass with a band of brilliant, reflective gold.
Once positioned, the waterslide decal is secured by firmly squeegeeing from the center outwards. This removes excess water. Emerging from the kiln, these crystal clear tumblers showcase the culmination of the firing process. The decoration is now permanently fused to the glass.
The logistics of moving thousands of glass products daily relies on this sophisticated network of wrapping stations and boxing lines.
Each tumbler receives individual attention, meticulously wrapped in soft tissue to shield the glass.
Here at the factory, every glass tumbler is carefully secured with our specialized bubble wrap, ensuring maximum protection during transit.
The automated erector system can form over 2,000 boxes an hour, ensuring a continuous supply for the glass tumbler line. Precision is key. Each tumbler is meticulously wrapped and placed within these specialized foam inserts, ensuring maximum protection during transit.
This specialized foam provides unparalleled protection, absorbing shock and preventing scratches during transit.
The automated sealing process ensures every box is perfectly secured, maintaining the integrity of the glass tumblers within.
This barcode represents the digital fingerprint of the shipment, linking the physical box to the vast logistics network. Quality isn't just a word here, it's a guarantee. That's why every single item is checked and approved before the final branding is applied. The logistics flow is seamless. Our automated system ensures that every box of glass tumblers is precisely.
In the modern glass factory, automation handles the heavy lifting, moving thousands of tumblers an hour.
Here we see the final stage of packaging. The automatic wrapper secures the glass tumblers for shipment, ensuring they arrive safely at their destination.
From the factory floor to the customer, our streamlined process guarantees efficient and secure delivery of every shipment.